Hello everyone, I welcome you again in series of C programming. In previous videos we have learned tokens like keywords, identifiers, constant, strings. In this video you will learn operators and special symbols. The topics covered in this video are operators and operands, types of operators, operator precedence and associativity, expressions, special symbols and assignment on above topics. Now what do you mean by operators in a C? An operator is a symbol that tells compiler to perform some specific mathematical or logical operations. Operand is the data on which operation has to be performed. Operator operates on operands. Now types of operators. There are three types of operator: unary operator, which operates on one operand; binary operators, which operates on two operands; ternary operator, which operates on three operands. Unary operators operates on one operand. Now first, unary plus and unary minus are two operators used to indicate positive or negative number. Next is logical not operator. It reverses the result of the expression. For example, if the result is positive, it negates to false, and if the result is false, it negates to true. Next are increment and decrement operators. They are special operators we will see in next part. Next is address operator, which gives the memory address of the variable. Next is size of operator, which gives the size of any data type like int, float, etc. Next is negation operator. It is a bitwise operator which complements the bits. 1 becomes 0, 0 becomes a 1. It flips the bits. Next is indirection operator used in pointers. And last is casting operator, which is used to cast one type to another type. Now we will focus on two special operators: increment operator and decrement operator. Increment and decrement operators. Increment operator increase the value of operand by 1, and decrement operator decrease the value of operand by 1. Now there are two types of these operands: pre-increment operator or pre-decrement operator. Next is post-increment operator or post-decrement operator. Now we'll see one by one these operators. Pre-increment operator. When we use the plus operator before the operand as a prefix, it is known as prefix increment operator or pre-increment operator. The pre-increment operator is used to increase the original value of the operand by 1 before assigning it to expression. Now what do you mean by this? For example, a equal to 10 and x equal to plus a. Now in this expression, first value of a will be increased first by 1, then assigned to x. So x will become 11 and a will become 11. So in pre-increment, value of the operand is increased by 1 and then assigned to other operand or other variable. Now in post-increment operator, we use the plus operator after the operand as the suffix. It is known as postfix increment operator or post-increment operator. In post-increment operator, original value of the operand is assigned first to expression or variable, then incremented by 1. For example, a equal to 10. In this, value of a is first assigned to x. So x will become 10. And afterwards, a will be incremented by 1. So a will become 11. Next is pre-decrement operator. When we use minus sign operator before the operand as a prefix, it is known as prefix decrement or pre-decrement operator. The pre-decrement operator is used to decrease the value of the operand by 1 before assigning it to expression. Means if the value of a equal to 10 and if I write x equal to minus minus a, so first value of a will be decremented by 1 and then assigned to x. So a will become 9 and then this value will be assigned to x, so x becomes 9. Post decrement operator. In post decrement operator we use the minus minus operator after the operand as the suffix. It is known as postphase decrement or post decrement operator. In post decrement operator, first the value of the operand is assigned to expression and then decremented by 1. For example, if a equal to 10 and if I write x equal to a minus minus, in that case value of a, that is 10, is assigned to first x and then value of a will be decremented by 1. So x becomes 10 and a becomes 9. Binary operators. Binary operators operate on two operands. Now depending type of operations, binary operators are classified into arithmetic operators, relational operators, logical operators, bitwise operators, assignment operators, and miscellaneous operators. Binary operators. In that first, arithmetic operator, it is used to perform arithmetic operation on operands. Relational operators, it is used to check the relationship between two operands. Logical operators, it is used to test one or more than one condition to make the decisions. Bitwise operators, which work on bits and perform the bit by bit operation. Assignment operator, which assign the value of expression or value of operand to another operand. And miscellaneous operator, which having some special meaning. Now we will see one by one all these operators. Arithmetic operators, these operators are used to perform arithmetic operation on operands. Now first operator is addition operator. It adds two operands. For example, if a equal to 10 and b equal to 20, so a plus b will give 30. Next, subtraction operator, it subtracts second operand from the first operand. For example, 10 minus 20 will give the result minus 10. Next is multiplication operator. It multiplies both the operands. So a into b will become 200. Next is the division operator. It divides the numerator by denominator. For example, b divided by a, 20 divided by 10, it will give 2. If both the operands are integer, result will be integer. But if the one operand is float and second operand is integer, result will be float. Next is modulus operator or mod operator. It gives the remainder after integer division. For example, suppose 5 mod 2, it will give remainder as a 1. Relational operators. These operators are used normally to compare the conditions or to form the conditions. The first operator is comparison operator called double equal to sign. This operator checks if the values of two operands are equal or not. If yes, then condition becomes true. For example, if a equal to 10 and b equal to 20, so a equal to b, so it is false condition. Means result of the relational operators are always Boolean, true or false. Not equal to operator. This operator checks if the values of two operands are equal or not. If the values are not equal, then the result becomes true. So a is not equal to b, 10 is not equal to 20, so result will become true. Determine operator. This operator checks if the value of the left operand is greater than the value of the right operand. If yes, then condition becomes true. 10 greater than 20, no, so it becomes false. Less than operator. This operator checks if the value of the left operand is less than the value of the right operand. If yes, then condition becomes true. 10 is less than 20, so it is true. Determine equal to. This operator checks if the value of the left operand is greater than or equal to the value of the right operand. If yes, then result becomes true. 10 greater than equal to 20? No. So it becomes false. Less than or equal to. This operator checks if the value of the left operand is less than or equal to the value of the right operand. If yes, then condition becomes true. 10 is less than or equal to 20. So result will be true. Logical operators. Logical operators are mainly used in decision making. Logical operators join two or more expression or condition and perform the logical operation on it. The result of logical operation is always Boolean, true or false. In C language, any non-zero value is assumed as a true and 0 is assumed as a false. Now C provides three logical operators: logical AND, logical OR, and logical NOT. Now double pipe is known as logical OR operator. If any of the operand is non-zero, then the condition becomes true. For example, if A equal to 1 and B equal to 0, so A logical OR with B is always true. Next, logical AND. Double AND is known as logical AND. If both the operands are non-zero, then condition becomes true. For example, if A equal to 1 and B equal to 0, so both are 1 and 0 becomes false. If A equal to 1 and B equal to 1, then it becomes true. Exclamatory sign is known as logical NOT operator. It is used to reverse the condition. If the condition is true, then logical NOT operator will make it false. Bitwise operators. C language firstly introduced bitwise operators. Bitwise operators perform on binary data but bit by bit. Now first, single AND is known as bitwise AND or binary AND. In logical AND there is two AND, but in bitwise AND there is single AND. It is known as bitwise AND or binary AND. Then single pipe, it is known as bitwise OR or binary OR. In caret is known as bitwise XOR. In tilde is known as complement operator or negation operator. Then two less than sign is known as bitwise left shift operator. Then two greater than sign is known as bitwise right shift operator. Now we'll see one by one all these operators. First we'll see truth table of bitwise AND, bitwise OR and XOR. Now if one operand is 0, if P is 0 and Q is 0, then P and Q will become 0. If P equal to 0 and Q equal to 1, then P and Q become 0. If P equal to 1 and Q equal to 1, then P bitwise AND becomes 1. Means if both the operands are set, then P and Q will be 1. If P equal to 1 and Q equal to 0, then result will be 0. Now P or Q. In this P bitwise or Q, in this, if one of the operand is true, result will be true. If P equal to 0 and Q equal to 0, then result will be 0. But if the P equal to 0 and Q equal to 1, result will be 1. P equal to 1, Q equal to 1, result will be 1. P equal to 1 and Q equal to 0, result will be 1. Now P XOR Q. In this, if both the operands are 0, both the operands are same, the result will be 0. If one of the operand is different, result will be 1. For example, if P equal to 0 and Q equal to 0, both the operands are same type, so result will be 0. If P equal to 1, Q equal to 1, if both the operands are same, so result will be 0. Now if P equal to 0 and Q equal to 1, result will be 1. If P equal to 1 and Q equal to 0, result will be 1. Now we'll see meaning of this operator. Bitwise AND or binary AND, it copies a bit to the result if it exists in both the operands. Bitwise OR or binary OR, it copies a bit if and only if it exists in either operand. Bitwise XOR or binary XOR, it copies the bit only if it is set in one of the operand but not both. Then negation operator or complement operator is a memory operator. It flips the bit from 0 to 1 or 1 to 0. Let us take example A equal to 60 and B equal to 13 in binary format. The first we see the operation bitwise AND A and B. So 0 and 1, 0. 0 and 0, 0. 1 and 1, both the bits are set, so result will be 1. 1 and 1, 1. 1 and 0, 0. 1 and 0, 0. 0 and 0, 0. 0 and 0, 0. So bitwise OR, in this if one of the operand is 1, result will be 1. So 0 and 1 becomes 1. 0 and 0 becomes 0. 1 and 1 becomes 1. 1 and 1 becomes 1. 1 or 0 becomes 1. 1 or 0 becomes 1. 0 or 0 becomes 0. 0 or 0 becomes 0. Now A XOR B. In this, if both the bits are of same 0 0 or 1 1, result will be 0. So 0 and 1, result will be 1. 0 0, result will be 0. 1 1, result will be 0. 1 1, result will be 0. 1 0, result will be 1. 1 0, result will be 1. And 0 0, result will be 0. Now complement operator, it has the effect of flipping the bits. 1 becomes 0 and 0 becomes 1. So in this, 0 becomes 1, 0 becomes 1, 1 becomes 0, like this. Now bitwise shift operator, left shift and right shift. In left shift, the left operand's value is moved to the left by number of bits specified by the right operand. In this bits in the MSB position is vanish and 0 is added into LSB position. In binary right shift operation, the left operand value is moved to the right by number of bits specified by the right operand. In this, bits in the LSB position is vanish and 0 is added into MSB vacant position. Let us see example of bitwise left shift operator. For example, 40 left shift by 1 bit. Now 40 is shown in a binary format. When we shift the bits at left side, 0 in MSB position is vanish and next bits are shifted to the left side. So this 0 is vanish and this 0 comes to the MSB position. So 1 comes to here. In the last, vacant position is added with the 0. So whenever we perform this operation on any integer A with an integer B, the result obtained after the operation is always going to equal to the multiplication of A with 2 raised to B. For example, if A equal to 40 and B equal to 1, result of the left shift operation is 40 into 2 raised to 1. That will be which will be equal to 80. Now bitwise right shift operator. In this we shift the bits right side. For example, suppose 14 right shift by 1 bit position. In this case, LSB bit is vanished and vacant bit is added at the MSB position. So this 0 will be vanished and 1 will be shifted to the right. This 1 will be shifted to here, like this, and MSB vacant bit is added with the 0. Note that whenever we perform the operation on integer A with an integer B, the result obtained after this operation will be equal to the division of A with the 2 raised to B. For example, if A equal to 40 and B equal to 1, the result obtained after right shift operation will be 40 divided by 2 raised to 1, which will be equal to 20. Assignment operators. Assignment operator assign the values to the expression or operand. So first, single equal to sign is known as assignment operator. A equal to B. The value of B will be assigned to the A. Then C language provides some shorthand arithmetic operators and shorthand bitwise operators, like plus equal to, minus equal to, like that. For example, A plus equal to 10. Then meaning of it is that A equal to A plus 10. B multiply equal to 10. Meaning of that is B equal to B multiplied by 10. It also provides shorthand bitwise operator, bitwise and equal to, bitwise or equal to, like that. Suppose A bitwise and equal to B, meaning of that is A equal to A and B. Miscellaneous operators. First is dot operator. It is used in structure or union to access the members. Then arrow operator, it is used in pointers. Then comma operator, comma is as a separator or operator. When we declare two or more variables of same type, in that case comma is used as separator. But when we use comma as a binary operator, then it guarantees that two or more expressions are evaluated sequentially from left to right, and the value of the rightmost expression will be served as a result of the whole expression. Now, what is the meaning of this? For example, a equal to, in round bracket, y equal to 2, comma y plus 4. So, inside the round bracket, y equal to 2 will be evaluated first, and this value will be used in the rightmost expression. So 2 plus 4 will be 6. So A will be the 6. Second, B equal to 10, 20, 30. So this value will be 10, 20, will be discarded, and rightmost value will be stored in a B. So 30 will be stored in a B. Ternary operator is also known as conditional operator. It operates on 3 operands. A syntax of ternary operator, it is mostly used in decision-making statement. So first part is test condition, second operand is expression 1 and expression 2. If the test condition is Boolean expression that result in either true or false. If condition is true, then expression 1 will become before the colon will be executed. If the condition is false, the expression 2 after the colon will be executed. This operator takes three operand: condition, expression 1 and expression 2. Hence it's called as ternary operator. For example, if A equal to 10 and B equal to 20, and if I check the condition 10 greater than 20, no. So value of B will be stored in a max. Next topic is operator precedence and associativity. Operator precedence is used to decide which operator has to be evaluated in an expression. In C programming, every operator has priority. When there are more than one operator in the given expression, then the operator with higher precedence or higher priority will be evaluated first, and the operator with the least priority will be evaluated afterwards. Now, operator associativity. It is used to evaluate the order of operators with equal precedence in an expression. In C programming language, when an expression contains multiple operators with equal or same priority, then we use associativity to determine the order of evaluation of operator. Means if the operator having equal priority, then we will evaluate the operator from left to right or right to left. Associativity decides the order of evaluation. Operator precedence table. Round parenthesis, square brackets, dot operator, arrow operator has highest priority, and the order of evaluation is from left to right. After that, memory operator has priority, and order of evaluation is from right to left. After that, arithmetic operators, in that also multiplication and division and mod operator having highest priority than plus and minus. After that, shift operator, in that left shift and right shift. After that, relational operators, in that also less than sign, greater than sign having highest priority than equal to and not equal to sign. Then after that, bitwise and, bitwise XOR, bitwise OR. After that, logical operators, in that logical and having highest priority. After that, ternary operators, they are evaluated from right to left. After that, assignment operator, they are also evaluated from right to left. And after that, comma operator, evaluated from left to right. Now we see what we mean by expression in C language. Expression in C language combine operands, operator and variables. The evaluation of expression in C happen according to operator's precedence. Once the expressions are evaluated, result will be stored in the variable. Let us see one example. In this expression, it contains multiple arithmetic operators. Now we want to evaluate this expression, so we have to use operator precedence. Now here in this, multiplication and division having highest precedence than the addition and subtraction. Now there are two operators having same precedence, as the multiplication and division. So in that case, we have to use the order of evaluation. Now arithmetic operators are evaluated according to left to right order of evaluation. So first we'll perform the multiplication operation. So 2 into 3 will be 6. After that we will perform the division operation. So 6 divided by 4, both are integers, so we will get integer division. Let us see one example. In this expression, it contains multiple arithmetic operators. Now we want to evaluate this expression, so we have to use operator precedence. Now here in this, multiplication and division having highest precedence than the addition and subtraction. Now there are two operators having same precedence, as the multiplication and division. So in that case, we have to use the order of evaluation. Now arithmetic operators are evaluated according to left to right order of evaluation. So first we'll perform the multiplication operation. So 2 into 3 will be 6. After that we will perform the division operation. So 6 divided by 4, both are integers, so we will get integer division at 1. After that, next operator will be 4 by 4. So division operator has the highest priority then. So 4 by 4 will be 1. After that, priority will be again by division operator, divide operator, 5 by 8. Now 5 by 8 will be, result will be 0. After that, plus has highest priority, so 1 plus 1, 2. After that, again next addition operator, so 2 plus 8, 10. Again here 10 minus 2, so it will be 8, and after that plus 0, 8 plus 0 will be 8. Thus operator precedence and associativity is used for solving the expression. Our last token is special symbols. These special symbols have special meaning and thus cannot be used for any other purpose. Now first symbol, square brackets. Opening and closing brackets are used as array element subscript or references. These indicate one-dimensional or multidimensional subscripts. Next is parentheses, round opening and closing round brackets. These special symbols are used to indicate the function calls and function parameters. In opening and closing braces, it indicates the start and end of the block of the code containing more than one executable statements. In colon, it is an operator that essentially invokes something called as initialization list. And next is semicolon. It is known as statement terminator. In C program, every statement is ended with semicolon. Next is hash or preprocessor. These are the directives start with the hash or header file start with the hash symbol. Let us see assignment on this topic. Short questions. List the unary operators, list the binary operators, define the term precedence and associativity, list the special symbols. Long question, explain the relational operators, explain the bitwise operator with example. At a short note on ternary operator, discuss the different unary operator, etc. I hope you will like this video. If you like this video, please share among your friends. Thank you for watching the video.